Now let me take the concentration terms better. What are the concentration terms presented in what solutions? Which concentration term generally we use actually? Concentration terms. First of all, what happened? Consider two beakers which contain solvent like water. I have taken water as a solvent. Now, what I am doing here, let us add solute like salt in both containers. Here and here I am adding what salt into both different quantities. I have taken 10 grams of NaCl here, 13 grams of NaCl. Solvent is what same. Solvent volume also same here. The volume of the solvent in both the case same, but what is the difference here? Solute also same, but how much amount of weight of the solute is different here. Now, which solution will be more salty and more concentrated? One will be a more concentration better.
Second one.
Grams of NaCl will be more concentration, correct? Now, why it is more salty? What is the reason behind this one? Because of what? More amount of the solute. If you have more amount of solute, less amount of solvent. What I am saying here, more amount of solute and less amount of the solvent, the concentration will have more in this case. So concentration depends upon directly proportional to weight of the solute, inversely proportional to weight of the solvent. Concentration can be called like concentration of the solution is the amount of solute dissolved in known amount of solvent. So what is the definition here? How much amount of solute you are adding in the known amount of what? Solvent is called what here? Concentration. What is the meaning of dilute solution?
Less number of solute.
In each less number of solute, more amount of solvent here. Okay, less number of solute, more. That means reverse to what concentration here. Right. Next, what is the meaning of concentrated solution? Means a solution in which solute is present in large quantity. Solute is present in large quantity. If solute is more concentrated, if solute is less, diluted solution. So difference between dilute and concentration solution. What is the meaning of standard solution? So this will come across in practicals. We see in practicals when you are doing what happened galvanometric analysis, standard solution will be there. What is the meaning of standard solution? Tell me. When you keep a solution on the stand, it's called standard solution. Keeping a solution on a stand is called standard solution. What is the meaning of standard solution? Anybody? Because you are the brilliant students, no. Tell me the answer. What is the meaning of standard solution? Yes? Standard solution means what? If you know the concentration of the solution, known concentration will be called as what? Standard solution. If anybody knows the concentration of that solution, is called standard solution. If you don't know that one, that is not at all called standard solution. And say what? 1 molar H2SO4 or 1 molar of NaOH is called what? Standard solution. If you know the concentration, that is called what? Standard solution. It's a very important one. From this, any other known concentration can be prepared here. For example, I have something 100 molar. I got 100 molar of solution. Now, by using this one, I can make 10 molar, 1 molar, 0.1 and 0.01. If you know the concentration of the first one, we can prepare by using this known concentration, we can prepare what happened, 10 molar, 1. If you don't know this one, we can't prepare what happened, any concentration of the solution. In examination, what happened, they're asking some volumetric analysis. In that, you have to prepare what happened, 1 molar solution. So for that one also, you need you can dilute that one by using what happened, standard solution. Which way is better to describe solution if the options are given? Quantitatively. Qualitatively, we can't explain that. Qualitative is nothing but what happened, what we are adding here. What we are adding, how much we are adding, that is what quantity. Quantity is how much we are adding. So quantity definitely explains the solution. It describes the solution actually. Can concentration be expressed in one way, two ways, or many ways? How much ways are there to explain the concentration? Or one way or two ways, or any ways? How many ways you are having? Yes, beta. Are you there?
Many ways.
Many waves are there. Now let me see what are the many waves you are having. Most commonly expressed terms is mass percentage, beta. Mass percentage. Now what is the meaning of mass percentage? Very simple. Weight of the solute divided by weight of the solution, not solvent, beta. Weight of the solute divided by weight of solution into 100, we get the mass percentage. We'll take example here. For all these examples, we'll take it. These are the examples. Normality we don't have in the syllabus. We'll discuss up to molality only. Okay. Formality is there, but formality, molality will come under. Except normality, we'll discuss everything. Now, first of all, we'll see the mass percentage here. Mass percentage. Now, W by W means what? What is the meaning of W by W? If I write W by W means what? Solute in solid state. Okay. Solvent also solid state. Now, first we represent solute. This is represented by what actually? That what about the solvent? That is also both are in what? In solid state only. In that case, W by W method. Otherwise, after resulting solution also will be, otherwise resulting solution you take it. Resulting solution also in terms of what again? In solid state. In solid state. Because you are making the solution. So solute in solid state, solution also in solid state. In that case, we can take W by W percentage. Now, what is the definition? The amount of solute dissolved in the, isn't it? Given amount of solution. Why I have taken 100 grams? Because 100 get cancelled. That is the reason I have taken 100 grams. If you take the formula here, mass of the component, that means solute, isn't it? Divided by mass of the solution into 100. Now, if I have taken here 100 grams, if I take 100 grams, no, 100 get cancelled. Now, mass of solute will be equal to what happened? Percentage, concentration. So here, the amount of solute in grams is called what? The amount of solute in grams is called what here? Mass percentage. If I take 100 grams, if I take here 100, what happens? 100 get cancelled, we get amount of solute in grams is nothing but called mass percentage. Formula is very simple. Now tell me what is the weight of glucose beta in this case? Tell me weight of glucose. What is the mass of glucose? Do fast. What is the weight of glucose in this case? How much weight is there, beta, in glucose?
35 gram.
35 grams only. Why? Because I told you no. The percentage will equal to what? Weight of the solute. If you take solution is 100 grams. Correct? So whenever if you take percentage, they given what? X percentage. The X will be what? In terms of grams of what? Solute. In that case, solution will be 100 grams. 100 grams, right? Like that we can easily solve this one. If you know the weight of the solute, how to calculate weight of the solvent? Weight of the solution minus weight of the solute. Already you know this one, I think. This is there in the textbook beta. You can observe in this question. Calculate the mass percentage of benzene and carbon tetrachloride if 22 grams of benzene dissolved in 122 grams of carbon tetrachloride. Now benzene will be what? Solute or solvent beta? Based upon the weight you have to say. Which is solvent? Which is
Solute.
Benzene is what? Solvent or solute?
Solute.
Solute.
Solute. Now tell me the answer now. Calculate the mass percentage of benzene. Tell me the answer beta. Formula? At least tell me formula.
The formula of benzene.
Weight of the benzene divided by weight of the solution. Don't take carbon tetrachloride. Weight of the benzene 22 divided by weight of the solution will be what? 144 into 100. Don't take easy beta. Don't do 22 by 122. Weight of the solute divided by weight of the solution. Now weight of the solute is how much here? 22 grams. And weight of the solvent is how much? 122 grams. Weight of solution will be 144 grams. Now the formula will be what? Mass percentage of solute is equal. Mass of the solute by mass of the solution into 100. Now mass of the solute is how much here? 22. Solution 144 into 100. The answer will be what here? 15.28%. If it is 15.28%, what is the mass percentage of solvent? Mass percentage of solvent will be how much better? How much it will be? Mass percentage of
84.
100
the remaining
100
percentage,
minus
remaining percentage will be mass percentage of solvent, right? Something 84.72% actually. So this is there in the textbook. You can do in your notebook now. Next we'll see the volume percentage better. What is volume percent means what here? Solute is in liquid state. Solute is liquid state. Solution also liquid state better. Both are liquids. In that case, we can take volume by volume. For example, alcohol percentage. Generally, alcohol percentage we can calculate by volume method. Volume of the solute in ml. ml is nothing but liquid state. Present in the 100 ml of the solution. Same formula. Volume of the solute divided by volume of the solution into 100. Now, when we get volume of the solute and volume percentage will be equal. If this will be 100 ml, then we get a formula. To raise the formula, we have taken 100. Generally, 100 ml we don't substitute. But for getting the definition, volume of the solute is equal to volume percentage whenever if your volume of the solution is 100 ml. Right? Now we'll take some problems over in this one. What is the meaning of 10% of ethanol?
10 ml of ethanol.
10 ml of ethanol present in the 100 ml of solution or 90 ml of water. 90 ml of water or 100 ml of the solution. What is brine solution beta? What is the meaning of brine solution?
10%
of
NaCl.
NaCl in water.
That will be W by V method here. But I'll discuss this in later actually. This is what volume by volume. Now 10 ml of ethanol present in 100 ml of the solution here. Calculate the volume percentage of 10% of ethyl alcohol in a solution of water. What will be the volume percentage? 10% of ethyl. Calculate the volume of the percentage of 10% of ethyl alcohol. What is the volume of ethyl alcohol? Very simple, I think. What is the volume of the solute? 10 ml. Solvent will be 90 ml. Definitely what happened? 10 like. Now this is important. Mass by volume. Most of the questions we get mass by volume only. That means most of the terms we use in that one, mass by volume. In this case, mass by volume, solute will be what? This will be solute. And the volume will be in solution. That means the resulting solution will be in the liquid state here. Right? The mass of the solute in grams. The mass of the solute in grams present in 100 ml of the solution. Call what? Mass by volume. This is very, very important for us. Formula. Mass of the solute by volume of the solution into 100 here. This formula is very, very important. Now we can take brine solution. This comes under brine because 10 grams of NaCl in 100 ml of solution. 100 ml of solution is called what? Brine solution. This comes under W by V method. We can do this one by W by V method. 10% means what happened? 10 grams of solute present in 90% means what happened? You can write like that here, in whatever the percentage. Now this is there in the textbook, I think. Calculate the mass by volume percentage of NaOH when 10 grams of NaOH is present in the 100 ml of the solution. What will be the answer, beta? Answer. What will be the answer, beta? Very simple only, no. Mass is what? 10. Volume is 100. Answer will be what? There. What will be?
10.
Last we'll see what parts per million. The number of solute particles are very less now. In that case, we'll take ppm now. When solute particles are very less, almost sure what happened? Negligible quantities, traces. Then we can take what ppm, parts per million. How many parts of solute present in 1 million parts of solution? 1 million parts of solution. 10 lakhs parts of solution is there. In that, how much part is solute is there? In that case, what happened? Formula will be number of parts of the solute, total number of parts of the solution into 10 to the power of 6. This is the formula we are using for calculating the ppm. Remember this formula, all of you. Remember this formula, all of you, right? For example, concentration of dissolved oxygen in seawater, because seawater quantity is more, but dissolved oxygen is very less. So we are explaining what with ppm. Concentration of pollutants in water also we can explain by ppm only. BOD, COD will explain in terms of ppm. You have seen in the 11th class. Whenever what happened, that pollution is what? 100 ppm. Then it is municipal sewage water we can take. 1 to 10 ppm is okay. But more than 10 ppm, what happened? Polluted. But if it reach what happened? 100 ppm, it is a municipal sewage water. Explain the importance of fluoride ion in water and any other use. 1 ppm of fluoride ion concentration in water prevents tooth decay. So 1 ppm is what very important for us. It should be there in the water, which prevents the tooth decay. So presence of 1 ppm is 1 part of fluorine in 10 lakhs of water. It's called 1 ppm. 1.5 ppm of fluoride ion in water leads to mottled teeth, isn't it? Higher concentration of fluoride ions in water becomes poisonous. So it should be what? At 1 ppm only. So this is importance of what ppm actually. Sodium fluoride used as a rat poison, in which what happened? The amount will be in terms of ppm only. Water pollution can be measured in terms of what? Which concentration, beta?
ppm.
ppm only. ppm. It's mole fraction. We take mole fraction lastly. What happened? 2-3 minutes it will complete here, because very simple topic it is. Mole fraction. It is denoted by x beta. X means like this, right? X like this. In this way, outer implement. So it will be denoted by x like this. Now, what is the definition here? Very simple. How many moles of solute present in? Here, moles we are taking beta. Moles we are taking. How many moles of solute present in? Number of moles of solution. The ratio of number of moles of one component to what? Total number of moles. Means total number of moles means what? The number of moles of solution. What is the meaning of total number of moles? Means the number of moles of solution. That means what I'm saying, how many moles of solute present in given number of total number of solutions. That is called what? Solution is called what? Mole fraction. Let me take one example here. A binary mixture I have taken. A binary means what happened? A plus B. So just imagine A is what solvent and B is what solute, like that. In that case, mole fraction of A is equal to number of moles of A divided by total number of moles. Means A plus B. Now we get mole fraction of A here. Now how to calculate mole fraction of B beta? Very simple here. 1 minus mole fraction of A, because in this case you have to remember like this here. Mole fraction of A plus mole fraction of B always will be what here? Is equal to 1 for binary solution. For binary. Isn't it? But ternary, A plus B plus C is equal to 1. So mole fraction of A is equal to is the number of moles of A divided by total number of moles. Mole fraction of B is equal to what formula? Number of moles of B divided by total number of moles. A plus B actually. So these formulas will be useful for you to calculate the problems. A solution having n number of components. Solution is having n number of components. In which what happened? Mole fraction of 1 is equal to total number of moles. Total number of moles actually. Total number of moles. You can take this formula actually. Very simple formula. The sum of the mole fraction of all the compounds always will be 1. For example, if you have what happened? Quaternary solution is given. Quaternary solution. In that case, mole fraction of isn't it? 1 plus mole fraction of 2 plus mole fraction of 3, mole fraction of 4 is equal to how much? 1. Like that we can. It is useful for what? Relating some physical properties of solutions like what? Vapor pressure something. It has no units better. Now this is very, very important term. Mole fraction does not have any units here. Understood better? Mole fraction do not have any units here. Why? Because if you see the formula, what is the formula here? Mole fraction of A is equal to number of moles of A divided by total number of moles. Moles get cancelled here. Therefore, we don't have any units here. Very important point. Following true statement, false statement, it will come here. It has no units. Which one? Mole fraction. It independent to temperature. Why? Because see what the formula mole means. What is the formula beta? Mole is equal to what? Mass by molar mass. Correct? Mass is what in solid? Molar mass is what actually is a molecular formula. So when you increase the temperature, solid concentration changes? No. So remember this one. It is independent to what? Temperature. It is also what? Very important for us. Next, mole formula is what? Weight by molar mass or gram molecular weight. Mole percentage is equal to what? Mole fraction into 100. So when you multiply with 100, what happens? That is called what? Mole percentage. Very important for you. Mole percentage means multiply this one into 100 here. Now let me take a question here. Calculate the mole fraction of H2SO4 in a solution containing 98% of H2SO4. Now, how do you calculate this one? Mole fraction of H2SO4. What is the formula? What is the formula? Mole fraction of H2SO4 is equal to number of moles of H2SO4 and total number of moles. Total number of moles. Now H2SO4. What is the solution here, beta? Solution is made upon by what? Tell me, beta. Speak out. If you don't speak, what happen? I will continuously take this class. Yes. What is this solution? The solution is made upon by what? Are you there?
H2SO4.
Remaining one. H2SO4 plus what? If you don't talk, what happen? I will continue up to what? 9:30. Other, if you talk, what happen? We will finish what happened in this problem, with this problem. Which one you want? Now H2SO4 plus what? Water here. The solution is made upon by H2SO4 plus water. In this 98% of H2SO4 by mass. What is the meaning of 98% of H2SO4 by mass means what? 98 grams of H2SO4 in which 100 grams of solution. 100 grams of solution. Understood here? What is the meaning of 98% of H2SO4 by mass? Means 98 grams of H2SO4 present in 100 gram of solution. Now, the weight of H2SO4 is equal to how much here? 98 grams. Now, weight of water will be how much, beta? Weight
10
of the
gram.
water will be how much?
Sorry, 2 gram.
2 grams. It will be what here? 2 grams here. Now, I have to calculate the number of moles of H2SO4 now here. I have to calculate number of moles of H2SO4. Now, weight of H2SO4. Weight of H2SO4 divided by molar mass of H2SO4. Molecular weight of H2SO4. Now, weight of H2SO4 given 98. Right? Molecular weight of H2SO4 will be what here? 98 only, better. So how much it will be? 1 mole. Similarly, number of moles of water. Weight of water divided by molecular weight of water. Weight of water will be how much? 2 grams. Molecular weight of water will be? What is the molecular weight of water?
18.
18. Now 1 is 9, 1 by 9. Now, mole fraction of H2SO4 is equal to, how much it will be? Number of moles of H2SO4, how much we got? 1. Put here 1. Again, total number means what happened? Number of moles of H2SO4 plus number of moles of what? Water. Number of moles of H2SO4, how much we got? 1 by 9. 1 by 9 is equal to, we get how much here? Calculate that one, 1 by 9. 0.11. 0.11. Plus H2SO4 will be 1. 1 plus 0.11. That is equal to 1 by 1.11. What will be the value beta? 1.1 by 1.11 is equal to how much here? 0.9. So what is the mole fraction of H2SO4 beta? 0.9 it is. Now tell me, what is the mole fraction of water?
0.1.
1 minus mole fraction of H2SO4. Why? Because mole fraction of water plus mole fraction of H2SO4 is always equal to how much here? 1. So based upon this formula, mole fraction of water is equal to 1 minus mole fraction of H2SO4, that is 1 minus 0.9, that is equal to what? 0.1 is the mole fraction of water. So in this way, we will get n number of problems better. How to do n number of problems here in this way. Understood? You have to do this problem. This is homework for you. A solution of sucrose in water is labeled 20%. Tomorrow you have to show this one. I will ask everyone, you have to show this one. Right? What will be the mole fraction of each compound? This is a homework for you. Note down this one as a homework here. And this one also you take as homework here. Calculate the mole fraction of benzene. Okay? This one also you take as a homework here. I given 2 problems for you, isn't it? 2 problems. Take as homework. With this, what happened? We finished mole fraction. Tomorrow we'll see the molarity and formality. Tomorrow we'll see the molarity and formality.